You know that the global navigation satellite system has a excellent accuracy, but the condition is that the antenna has line of sight visibility to at least 4 satellites. So if the condition is, or if the at least 4 satellites are available, then excellent accuracy we can get through the GNSS. But when the line of sight to satellites is blocked by the obstructions such as trees or buildings, navigation becomes unreliable or impossible. So at this juncture, the GNSS receivers work with other sensors to provide position and navigation. And that sensor, we can say that the inertial navigation system. Inertial navigation system or INSS uses rotation and acceleration information from an inertial measurement unit. So this is the important one, that is IMU or EMU we can call, and it will compute a relative position over time. A NU or inertial measurement unit is made up of 6 complementary sensors arrayed on 3 orthogonal axes. On each of these 3 axes is coupled an accelerometer and a gyroscope. The accelerometer measures linear acceleration and the gyroscopes measure rotational acceleration. With these sensors, an AMU can measure its precise relative movement in 3D space. The INS uses this measurement to calculate the position and velocity. And the additional advantage of the EMU measurements is they provide an angular solution about the 3 axes. And this angular solution into a local attitude, roll, pitch and azimuth solution, which it can provide in addition to the position and velocity. So by this we can say that it not only provides position, velocity, and also it will provide the local attitude. Now, the ability of the INSS to provide attitude determination is an important addition for several applications such as aerial survey and hydrography. Now, you know that for aerial surveys, it needs the local attitude, roll, pitch and azimuth. These parameters are needed for aerial surveys, and in these applications, this will be used. An EMU provides these accelerations and rotation to the INS system as a discrete measurements at a specific frequency. INSS has their own drawbacks. The first one is that INSS provides only a relative solution from an initial start point. This initial start point must be provided to the INSS. And second is that, more critically, the high frequency measurement provided by the EMU include several error sources. INSS system will drift from true position quickly without any external reference. Now, providing an external reference to the INSS allows is to estimate the errors in the EMU measurements using a mathematical filter and mitigate their effect. That external reference can quite effectively be provided by GNSS. So, by providing that, an absolute set of coordinate that can be used as initial start point, as well as GNSS provide continuous positions and velocity thereafter, which are used to update the INS filter estimates. So both the drawbacks, whatever we have seen before, that can be rectified through the GNSS by providing the initial start point and also by providing the external reference. When GNSS is compromised due to signal obstructions, the INS system can continue to navigate effectively for long periods of time. Using GNSS positions and velocity to estimate INSS errors is called as loosely coupled system. However, GNSS plus INS combined systems can get much more elaborate than that. So we can also call this as a tightly coupled. So you see this figure where we can see the inertial position and velocity. In the left side, the GNSS filter can determine position, velocity and clock offset or carrier phase ambiguities. And in the right side, inertial filter which have position, velocity, attitude, gyroscope errors, accelerometer errors. This all can be rectified by using this GNSS filter. Thus, when GNSS and INSS are combined, the two techniques enhance each other to provide a powerful navigation solution. So this is the technology about the combination of this GNSS and the inertial navigation system. Now, there is a important term in this that is called as sensor fusion. A term growing in popularity in this field is sensor fusion. Increasingly, it is not just GNSS or even GNSS plus INS. It is an amalgamation of any and all available information to create the most robust and accurate solution available in all conditions. All of the input technologies, GNSS, INSS, cameras, odometers, digital elevation models, range sensors, etc. are taken into account. And this amalgamation, we can call it as a sensor